This is my IDS2 project. It's a food storage and heating device for kayak fishermen. I started by reviewing the brief and assessment criteria which allowed me to define my research. For my research, I went to go outdoors to identify trends in camping equipment and food heating and storage devices on the market at the moment. I found that silicone outer shells were very popular. I also found that the pre-cooked food packets were very popular, as you only needed to submerge these in boiling water or heat them up using an exothermic reaction. These are the most popular gas stoves on the market, however they wouldn't be suitable for my user's environment. I bought some flameless ration heaters online to test to see if they would be suitable for heating up the food. I found these MRE packets where you put your food packet in the outer shell. You then place an exothermic reaction tablet on top, pour in water and seal it up and let it go for 8 minutes. These are the slides of me testing it out. The main positive was that these would be safe to be used on the kayak, as there was no flame involved. They're very simple to use and are hard to mess up the actual heating process. However, the negatives are they would be hard to mount on the boat. It's a rather inelegant solution. It doesn't have much industrial design merit. The water in the packet becomes contaminated, and I don't know if that probably wouldn't be safe to be let into an aquatic environment. As you can see, it's irritant, corrosive, and a fire hazard. They get very, very hot and there isn't very much protection from the user, so there could be a problem with scalding. I also then reviewed a very small solid fuel stove which could heat up 2 cups of water in about 5 minutes. So you placed one of the cubes on the stove to heat up, you then lit it, you put your mess tin on top. I found these were a great little portable solution, but as I wanted my food device to be used on a kayak, I don't think this would be safe having a lit flame on board. I then started filling out the giant IDS checklist, where I started coming up with my persona and rough ideas of where and what my activity is going to be. Went through some of the group research, so have thought about the different fuels and the amounts of fuel that are required. I've also thought about the different graphemes from the brand Land Rover and some more testing of different heating devices. Here I have just outlined the different technology and how it's going to be transported around the site and what the actual specifications are. Here's a storyboard of the user, how the user will actually use the device. I've aimed it, as you can see, it's being used on the actual kayak, not on land, and will be used just by filling up the water from the lake. So there'll have to be a way to prevent the exothermic capsule from reacting too quickly when you're filling it up. Here is a mind map of my initial thoughts on the device and how it will work, with some analysis of the issues that I've found. I found that you would have to have a flameless device, where the MRE excels at that, and I haven't found many other efficient systems. The MRE is a very efficient system. Here is a brainstorm of the use environment and how it would fit in with the aesthetic of my device. Some initial thoughts on products that are out there in the market at the moment, and just kind of bits of brainstorming about the Land Rover brand and how it could be a tool more than a product. It's a tool for heating up food. How I could introduce some kind of aeroplane kind of grade feel to it. That was my thoughts on this board. These is just another mood board of the outdoor kind of use environment it will be in. Slide shows the calculations of how you can put 500 ml of water in with the exothermic capsule and produce heat. Decided to do some more work on the persona to make it more real. He's part of a Land Rover Appreciation Society and enjoys all British engineering. The user gets much more enjoyment eating food with cutlery than just drinking the food. Also, from my initial research, I found most users wanted to have a soup or a stew on their boat, and this would be very dangerous to kind of drink through a straw. So all of my concepts have been based on using cutlery to eat with. So here's some ideas of just a pot where the spoon has actually become part of the handle. The exothermic capsule is all housed in this compartment and then placed inside it from the base or the top. Here's some ideas with a valve that would allow the air and water in to the capsule, and then you'd press it in to activate the actual reaction. Here I thought you could wrap the food packet around a spindle. The solid fuel would be placed in an internal container, and there would be an outer sleeve that would hold the entire reaction together. Here are some ideas on some forms. Here are some ideas of the outlines and different side profiles that I could have for this device, trying to make it. The base would attach directly to the kayak, and the flask would be stabilised inside it. The flask would attach using a suction cup to the plastic outside of the kayak. On this slide, I experimented with different forms for the base. I used Photoshop to create a mashup of different parts of Land Rovers and applied this to my flask. I then went on to review my sketch models with a colleague. I thought about where the product's actually going to sit in the cockpit of the kayak, and possibly having a design that would allow it to sit between your knees on your lap. I was experimenting with different toggle switch designs for unlocking and locking the suction cup. Here I was looking at having the exothermic capsule beside the food capsule, so they're actually in different compartments. And this was just some thoughts about how the lid features would attach, and more views. I've created a scenario of use of my mock-up to show how the user will interact with the device. Firstly, you would unscrew the exothermic capsule from the lid. You would then place the exothermic capsule inside the holder, replace the lid onto the flask, then you'd attach the base onto the body of the kayak and the flask within. I decided to have a go at designing a more lunchbox style device. However, as the MREs are all open from the top, this would make eating the actual MRE much harder. I use SolidWorks to form renders of the different packets in the device to allow me to sketch over it to ensure that all of the components would fit. I have created a summary of all of the insights and ideas I have had so far. The flask form is quite hard to spoon out of, and since eating using cutlery is a must for my product, then based on my research I have decided to have an external silicon outer shell and eat out of the internal MRE packet. I have written down why the exothermic reaction is the best heat source for my product. It's simple to use, it's safe, waterproof, which is useful for the intended environment, cheap, you can buy them for £1.19 on evacuate.com. They're quick, they only take 8 to 12 minutes to heat up, but there are also considerations like making it easier for people to dispose of the contaminated liquid inside, and also the reactions are only single use, so you'll have to carry multiple packets for multiple meals. I've thought about the hygiene issues with using the device whilst kayak fishing. You are only warming up food, not cooking it, therefore it's safe to eat at any temperature. If you had raw ingredients, then keeping them cold would be an issue to prevent them from spoiling. The lid could have thermochromic paint on it to display when the food packet is up to temperature, and a built-in safety knife or scissors could cut the packet top to prevent you from needing to get your fingers anywhere near where you will have to eat from. I'm going to directly attach the device to the kayak and not to the person, as this would be too dangerous. The carabiner will attach through a rigid hook which will be screwed into the wall of the kayak. There will be a quick release clasp which will have rope that will connect it to the carabiner and to the device itself. Here is my final design. There is a expandable silicon outer moulding, a plastic and metal top and bottom. There is a drawer in the bottom which houses a foldable spork and any more exothermic packets you will require, and the lid with the metal reaction capsule encased in the top. I thought about the manufacturing of the device. I've decided to use blow moulding as this can create the geometry easily. And here is a summary of how I'm going to produce the rest of the parts.